In Chapter 12, we introduced the concept of heat, and in Chapter 6, we studied work and energy. And although we studied these topics independently, they often occur together. In an automobile engine, for example, fuel is burned at a relatively high temperature, and some of this heat is converted into work to move the pistons in the engine up and down. The excess heat that is created is removed by the car's cooling system to prevent overheating. In this chapter, we are going to study the branch of physics known as thermodynamics, which is built upon the fundamental laws that are obeyed by heat and work. In thermodynamics, the collection of objects under observation is known as the system, while everything else in the environment is called the surroundings. The system and its surroundings are separated by walls of some kind. Walls that permit heat to flow through them are called dithermal walls. Perfectly insulating walls that do not allow any flow of heat from the system to the surroundings are called adiabatic walls. In order to understand what the laws of thermodynamics have to say about the relationship between heat and work, it is necessary to describe the physical condition or state of the system. We might, for example, be interested in the air within a hot air balloon. The hot air itself would be the system, and the skin of the balloon would provide the wall that separates the system from the cooler air outside in the surroundings. The state of the system would be specified by giving values such as pressure, volume, temperature, and mass of the hot air, for example. There are 4 laws of thermodynamics that we will discuss in this chapter. Let's begin with the one known as the 0th law of thermodynamics.